Hi, hello everyone. Is anyone in the channel? So this week I changed my schedule a little bit. I'm planning to start weekday evenings and Saturday to stream. Last week, like I just did all that only on the Saturdays, but that stream worked very well out. I did GraphQL, Node.js on Nest.js framework, which worked very well out. But only on Saturdays, that's giving like a long gap between two sessions. So that's why like I just changed my schedule a little bit to do on Monday, Wednesday, Thursday, 8 p.m. EST, and Saturday morning, 9 a.m. EST. So this is my day schedule. So if you want to join with me, then come by, and we will have like a good time together here. So this week I'm going to start like a new series. This custom mission API. So there is a Microsoft custom mission API. So in this week, like we will be seeing this API in the main. In this week, like we will be seeing first we will see like what is custom mission. Most of the people will know what mission it is. And I have done like the similar project in custom mission and also in Google Cloud AutoML. But this time I'm going to create in the custom mission and try to do the real project in the sense like how the custom mission apply in the real-time scenario. So I am trying to build a reference architecture here, or like a sample application, how the custom mission will work in the IoT device. So that's what I'm planning to team for like in coming weeks. So let's see the custom mission. So today the first thing we are going to do is how to prepare the data sets and all. So that's the first step. Let's see. So you can see the step here. This is a Microsoft have like a lot of cognitive services updated. So cognitive services in the sense like wherever the machine is doing the human-like capabilities, such as seeing, hearing, vision stuff, and try to understand like what human is saying. So those kind of things that is provided in the Microsoft cognitive services. So this time we'll be going to look at like what are the different type of Microsoft cognitive services. So if you can look at here, so they are having a vision service, knowledge, language, speech and search. So this is like the high level thing, what is machine doing in that in the AI to solve the problems. So in our case, we are going to look only that the vision thing. We are not going to look at like the speech, knowledge, search or language. Probably we will cover in that the different series in the different thing. But right now we are going to look at only that the vision. So we will go and see like what is the vision service looks like. So in the vision service, we have like more subtopics here. One is the computer vision. It's do the image classification, scene and activity recognition in images and all. Let's try that one. Okay, I think I already have an Azure account. Even if you want like the free Azure account, they are giving like $200 credits. So $200 credits for that $200 you can post your resources in Azure. So you can have this one if you want to try the free Azure account. I already have this Azure account for my account, so let's try that one. I often forget what it is. Okay, I am into my Azure portal. Let's go to the customvision.ai and okay, we are in the cognitive services. Going for vision here, and that's a demo. I think this one is to try for free. In our Azure portal, we need to set up our key and try this computer vision. I think we need a demo to run in the browser itself. Okay, I will go for this demo, scene and activity recognition. Yeah, this is the demo I expected for. So you can see like how this computer vision works. So there is a two set of things in this AI spectrum, right? One is there is a common problems and there is a common solution for that problem. What does that mean is like you can have like detect what object it is and whether this image contains a train, building, indoor, those kind of the common objects. That's already like the lot of machine learning models that is provided by Microsoft. They already know what the object is. So it's going to try its like the common problem. For example, here let's see. So for this image, it knows like this is water, sky, cloud, and sun. So those are the things it's trying to extract from the image. So if you want like this kind of common tags or common characteristic you need to extract from the image, then probably you can go with that computer vision, right? So computer vision, we are just providing the image, and through the REST API is going to get all the description. For example, here it's getting the description like water, outdoor, ocean, blue, this kind of tags that is available in this image, and also it's saying like how much confident it is. For example, here it is sky is like a 99.99% confident, and water is 99.97% confident. But if it's going like a very low, then you can see like a here cloud is like it's only confident like 0.08%. I'm not sure like why cloud is 0.08%, but the machine understands in the sense like it is only 0.08% confident it has cloud, but it is like 99.9% confident that it has sky and water. So everything is like based on that the probability only. Machine learning is like not a exact accurate science. It's only based on like it's based on like the prediction. It's predicting like okay, it has sky since it is like a blue in color, and there is a cloud in the sky. So there are a lot of characteristics that's come into the picture, and it's recognizing like it is some percentage confident about that prediction. So that's how like the computer vision works. So it's bringing like other thing, including the content maturity. It's not like having the adult content, and there are other things. It's doing like the pre-analysis of these images, and also it's doing like a face detection and what dominant color background it has. And so you can go to this link customvision.ai or sorry, the azuremicrosoft.com and cognitive services computer vision, and you can try with this browser image. And also if you want to try by your own, you can just go and generate your API key and try with your own image. Now let's see like a couple of things here. It says like it has table, food, and indoor sitting, and donut and all. That's cool, right? So this is the things we need for like a computer vision. Basically this computer vision is like a machine learning trying to predict or trying to see as human. So if human is seeing, so it would be helpful in the real time scenarios, like if a human wants to see certain things but there is some human unreachable area, or it's like too much process for that, then this machine or for example like a drone can drive into like a deep caves, and it can understand like whom to rescue, and differentiate between the objects, obstacles, those kind of things. And also like wherever the automation comes into like the big manufacturing stuff or mining industry, in those places these kind of computer vision would be helpful. So that would be like the big change for like our humanity, right? So this would reduce like a lot of workflow, and also like it can achieve certain things which is not capable of ours, and still that machine can reach into that. So those things, this would be helpful. So as I have said before, there is a spectrum of artificial intelligence. One spectrum is um, these common problems, common solution, and another spectrum, another end of the spectrum. What if you have like custom domain scenarios? For example, I think we already have this build conference to classify like whether the image is hot dog or not hot dog, or to classify between cat and dog. So this kind of image classification or object detection, those kind of things, for the domain specific, Microsoft is providing like services for that as well, and that is called custom vision. So this is called computer vision, common problem, common solution, and there is a custom vision. So in this custom vision, what it's going to really do is it would be easily like customize your vision models. So we are bringing our own labeled images, and using custom vision service, we are tagging like what that object is. For example, take an example of a hot dog or not hot dog itself. In that case, hot dog or not hot dog itself, in that case we are taking a hot dog, we are uploading like images having hot dog and not hot dog, and once that is done, then we are labeling the images as like what is hot dog and what is not hot dog. That is uploaded, and once we label the image, then we are going to train the model. So using our labeled images, we are going to click the train button in custom vision portal, and that's going to internally like take all the images and analyze the label attached to that image, and it's doing like generating the machine learning models, and it's giving like the custom model built for these images, for your domain images, right? So let's once we have uploaded and once we have trained, and it's the machine learning model is generated, then you can evaluate that model using a REST API call. So Microsoft custom vision is going to provide a REST API call that includes the prediction result, right? So if you are uploading an image that is not uploaded before, in the upload images, right? So take that one and try to predict that using the REST API. Then the prediction result will give like whether it's a hot dog or not hot dog, or whatever the classification you trained for, and it's giving the confidence score as well, like whether it is 89% confident or 50% confidence. So whatever the low percentage confidence, that means like still your model needs to tuned up. Otherwise you need to you can like have this prediction version, or like once a model is tuned and once a model is perfect, you can use that model for predicting your REST API. So that's how this custom vision works. So couple of things I'm going to do in this custom vision is, so the first thing I'm going to like get the data set. So the main problem in the custom vision is like we are going to give our business domain dataset, right? Usually the business will, they own their images, they own their data. For example, like if any a restaurant based thing, not the restaurant, or like if some manufacturing company, they would be owning all their data, so they are like taking the pictures of like the manufacturing process, each and every process, or like they are taking the product, uh, they are taking a picture of the product at each manufacturing level, so that like they can easily identify, okay, this product is like still in this stage 1, this product is in like a mid stage, and this product is like a completed product. So they can like classify between those stages, so those kind of things. So if you own the data, there is no problem, because you have like a lot of data, so you can just like upload the data after like a fine-tune that, and you can train that and evaluate that. But for learning purpose, you will not be having like a too much data for that. So in today thing, like we are going to see like how to prepare the data, or like what are the different open data sets available. So we will go through the open data sets and see like how we can extract the data sets from how we can use the data sets in this customization portal. Okay, so the first thing, I will sign in here. Agreeing the terms. Okay, I already have 2 projects. I think this is still in that training mode, so I'm going, yeah, it's still in the limited trial. So I'm going to delete this, and let's start a new project. Now we will be creating this new project. So here you can see like the create new project dialog that's getting a couple of properties. So the first thing is project name and a project description, and there is a project types, whether it's a classification or object detection. So classification in the sense like it's going to classify between the images, whether it's like a what kind of flower it is, what kind of clouds it is. So basically like this is your product or your image dataset has like multiple classification types, and using this project types classification, it can classify between those images. And other thing is object detection. So the object detection is like it's going to detect the object, and also it's going to give the bounding box like where that object is located. So that is for this object detection. For our case, we are going to look at this classification only. And in the classification, there are like a different types, classification types. So one is a multi-label and another one is multi-class. Multi-label is like a multiple tags per image, and multi-class is like single tag per image. So what is multi-label is like if it is in the same image, you want to identify as like a different tags in the same image, then go with the multi-label. Or otherwise it's like only single tag, then go with the multi-class. So let's go with the multi-class, single tag per image. And the domains, so these are the domains that is available in this customization portal. So if you choose this domain, then the customization portal will pick up like the machine learning algorithm, which is good enough to find these domains. For example, if you want to classify between the food or fruit or vegetables, so these kind of food domain, then go with the food domain. Begin the scenes, the customization portal that's going to pick up your machine learning algorithm to identify like a food with a higher prediction, so it's going to pick up that food domain. Similarly, you can choose like landmarks, retail, and other stuff. What is the compact edition in the sense like if you are using the domain in any IoT devices or even in the mobile itself, you want to do this classification, you want to do this machine learning in mobile, then you need to use this compact domain, right? Hey, welcome guys. If you have anyone joined, thanks for coming and watching. So today we are going to today we are seeing like what is custom mission and how to prepare the data set for the custom mission and all. If you have any questions, then chat in the stream, and thanks for coming and watching. So today we are looking this classification type, right? So if you want to use your machine learning classification in domains, that means like in mobile or in IoT devices, it not doing like machine learning in the cloud, but if you want to do it in like in your compact devices, then choose this compact domain. So what is that compact domain? Means like it's going to export the model, the machine learning model, into your device itself. So that means like you can export the 4ML model or Android model into your devices and run this classification without hitting any cloud itself. So that's what this compact domain. So let's create a project. Before that, like to find the data set, let's go and find the data sets. Like there is a open data sets available specifically in the Kaggle, so you can get the data sets for machine learning and this kind of classification. Otherwise, what would be need to do is like you need to take the pictures, or if you own the data, you need to take that. I think a couple of images is fine, but for like a higher prediction, you need to use more images. So I would suggest to go with the data sets to upload like the entire data set that is available publicly. There is no and like you can choose the license, what license you want to use, right? So you can play with that so that like you can completely understand like what is tuning that machine learning model. Even the custom mission is taking care of like generating a machine learning model. Whatever you are giving the input, that needs to be like the high quality data, and also you need to take the pictures in like a different environment, different angle, those kind of different probabilities that real-time situation going to come is, right? So for that thing you need to take like those pictures. Otherwise I would suggest to go with these data sets only, and you can filter this data set. For example, for us, like we are going to look only the image data, so I'm choosing this image data, and let's see like what are the different domain that is available in this image set, and we will see whether we can choose this one, right? So they have this Stanford dogs dataset that is having like a 20,000 images of 120 dog breeds. So if we want to classify between the dog breed, then we can go with this. And they have celebrity faces, 9 million URLs with labels in the 6,000 categories. That is, I think this is the big one. Yeah, it has Google BigQuery stuff, and they're having like the sign language digit data set. Let's go and see. Oh, they don't have any images here. Yeah, images of Lego bricks. Yeah, this is the good thing. Clever recognitions, hand gesture recognition, fruits. So if you want to classify between the fruits, you can go with this data set that contains like a 65k images with the 95 fruits categories. That is like amazing. Blood cell images, Stanford car. Yeah, board types recognition. I think we can take this one to classify the boards. Let's see like what are the different category of boards it's trying to classify. Okay, it has cruise, ferry, freight, gondola, kayaking, paperboat, sailboat, and each has like a certain number of files. I think this should be fine. So we will download this one. I already have the account, I think. Oh, 1 second. I already. Okay, I will sign in with this. Okay, now it's downloading. So let's download this dataset. We will upload this dataset into the custom mission project and see like how we can tag those stuff and all. So before that downloading, we will go and see like, okay, here we will create the project. So boat classification, I think boat, I put like a, let's go, classify between different boats or classify boat types. Classify boat types, it contains like a classification, multi-class, single tag per image, and I would go with the general itself. It doesn't fit into food domain or landmark domain, I think even in the retail, but I will choose like a general compact so that we can later test it in that IoT device or from the mobile application. So let's create the project here. Yeah, now we need to upload the image from this portal. So for that one, it's I will see whether it's downloaded or not. Okay, it's downloaded and it has like each folder. First I will see like what's the pricing model for this custom mission so that we can easily understand like how many images we can download, right? I think there is a different pricing model for custom mission service. For example, like the training thing, you can upload only 1000 images or something like that. So let's see. So the custom mission service, I think it's available in the South Central. Yeah. So the free thing contain like up to 2 projects you can create, and you can do like a 5000 training images free per project. So we can upload up to 5000 images and 10,000 predictions per month. I think this is fine. Otherwise, if we go with the standard, they're having like a $1 per 1000 transactions and $0.35 per 1000 images. I think we can do image storage as well, right? I think it's going to store in like Azure storage service. So let's go with the free instance only. Let's do this stuff. Back to this. So 5000 images, and I think this folder contain like a 1 2 3 4 5 6 7 8 9 categories. At least if you are uploading 100 images, I think 5000 images would be fine, right? Let's go and see like how many files it has. 540. I think it would be coming under 5000. So let's upload that. So the first thing I'm going to do is like upload all the image from each tag, and I'm going to add the tag as like what is the tag for that? Upload all the files. It's uploading in the custom mission portal. Okay, 68 images upload successfully, and the biomes contains like whatever that is floating in the water. Yeah. Okay, now the other images are going back to the boats, taking the cruise ship, selecting all images, uploading, and I'm typing the tag as cruise, and it's uploading 239 files. Let it be. Okay, I think it's uploading like a 128 files. Let's see. Okay, then ferryboat. I think ferryboat has less images. Or probably like we will upload less images for that. Let it finish. Okay, so cruise has 239 images. Let's go with the next tag, ferryboat. Probably I'm going to upload like less images later, then we will fine tune that. Yeah, I'm going to upload like a few images only, 27 images. Let's see. So ferry, okay, the ferry image is uploaded. You can see that how they're having the data set, right? So they have taken in like a different angle, different quality. For example, like this is high quality ferry boat, and this is like a front of the ferry boat. So they have taken like the different quality and also like the different thing. For example, here the ferry boat is here with like the background is different. So those kind of things, that's so those things will be like improve your prediction model pretty quick in the real-time scenario. So if you are like implementing this excuse me, if you are implementing this custom vision project into like a real-time project or real-time use case, at the time like you would not expect in the same type user is also going to take the picture, right? So for that case you need to do like a more different types for that image. So we have uploaded a ferry, then freight boat. Going back to the boats, freight. This also I'm going to take a few images, 27 images. Freight. Then the next thing, gondola. That's how like another let's upload these gondola images. And what are the different categories they're having? Inflatable, I think. Okay, we'll do kayaking paperboat. Okay, I will do like inflatable kayak and sailboat. I will ignore this paperboat because that's not the real-time thing as well. Let's see like how the paper, yeah, I don't want to include this paperboat into this thing. So I'm going to upload like a inflatable kayak and sailboat, or like even inflatable I would skip. I would upload like a kayak and sailboat. So let's go for the kayaking. Okay, so kayak, I have uploaded another 42 files in the kayak boat type. Okay, kayak is uploaded, then we are going to upload the sailboat. Sailing boat in summertime in Florida, that would be amazing, right? So sailboat, uploading another 40 plus images. Okay, that also. Okay. The sailboat contains like including the vector picture and the real-time picture. Okay, that's cool. So once you have uploaded all these training images, you can go and click the performance. Okay, so one other thing I forgot to say. So so this is like this process is like trying to classify between the different boat types, right? If example like what if user is uploading which is not boat, so we need to upload like a certain amount of images which is not fit into like in these kind of any categories. For example, like let's go and random images. For example, like this I would say like I'm just looking for like images randomly or general images. Oh, general means like it's going here. Okay, I will take like one cat picture. I would explain like what does that mean. So I'm taking one cat here. Before that, I will choose the license label for reuse. Okay, I'm taking this one cat and I put it in the boats category here. So what we need to do is we need to add the images which is not boat. For example, here I'm uploading the cat image, right? So why we need to upload these images is like the customization portal is trying to classify the boat image, but what if user is uploading like the image which is not boat? So here you need to go and upload like these kind of not boat thing, and if you go to the my tags you can see the negative thing. So what is that means, like you need to use this negative tag that's not that depict the visual subject of any other tag. So you need to upload these kind of negative thing, so that like if you are uploading the cat and ask the system like what kind of boat it is. Otherwise if you didn't upload this negative thing, the machine learning model confuses and it tries to identify the boat in this cat image. Then it's giving like the it's giving the prediction like some boat, right? For example, like it's trying to say this as like a ferry or something like that. To avoid that one, you need to upload these kind of general images which is not fit into that category you are trying to classify. We are uploading only one image here, but let's see how this perform here. If it needs more negative type image, then probably we can add it more. Now here you can go to this performance to see like how this machine learning model is performed. So for that you need to train the model here. Let's go and train it here. Okay, your project can't be trained just yet. Make sure you have at least 2 tags and 5 images for every tag. Oh, okay, I have like a lot of tag, right? Is there any untag? No. Oh, is it looking for this one? 5 images for every tag. Okay, let's take this kind of general picture. I took one picture in animals. Let's take like fruit. Let's take this one. I'll make sure again I'm still in the reuse. Okay, do not like take all the Google images. Some images are like it's a copyright image, so make sure you are choosing your permission types here. Go to tools and select label for reuse, and if you choose the license type, then you can get your image. I choose like a label for reuse so that I can reuse this image. So for back to this, for the negative tag, we have uploaded animal, fruit, probably like airplane pictures, flight pictures. I think this would be fine. Flight, fruit, using that negative tag, uploading the picture. So I have uploaded like 3 images for negative tag. Now I can train, I think. Your project, why it's 5 images. Okay, sorry, I thought like it's a 3 image. So fruit, animal, flight. What are the other thing we can have? Train. Train picture. The next thing we can do is probably car pictures. Let's take this car. Okay, I think I have 5 images, right? Car, train. Control. Okay, I will upload one by one. Adding negative tag, uploading file, adding another image in the same negative tag, train, go choose, and make sure it's doing the negative tagging here. It's uploading the image. I have 5 images for every tag. Okay, once I click the train, then it's starting like the iteration. So you can like upload any number of images even after you have trained your model, and this would be doing like training the model in iterations. And once the iteration is done, then you can choose that model ID for prediction. Now it's training, so let's wait and see how it's trained. Oh, they have this get started thing also. So this is what we have done, like we have created the project, we have uploaded the images, tag our training images, and training our project. Okay, so the trained result came, and it's a 88.6 percentage precision rate. That means like it's 88.6 percentage confident like this is going to predict correct, and recall rate is like 85.2 percentage. If it is like close to 99 or like 100 percentage, then that means like our data is correct and it has a good amount of thing. Okay, there are a couple of red thing here. So each tag precision rate is like mentioned here, and I think the ferry is having low precision, so sometimes it might confuse to detect this ferry type. And in this recall stuff, I think the lower one is buoyance, yeah, and it's having the unbalanced data detected, so it's not like evenly distributed. For example, like if it is having 239 images, then at least like these things needs to above like a 200 or around 100. So let's have this one, and we will iterate this upload dataset, and we will do that thing. So this citation is ready, and to make a default, then you can just like make a default. So if you have like multiple iterations here, and if you want to choose like the specific iteration to be a default one because that iteration is performing very well, then you can just select the iteration and mark it as default. So the prediction URL is here, and you can use this one, like the prediction key. I'll be rotating this one after this session. So you can use this prediction URL. Now go and do the predictions, and let's see like how this is performing very well, right? So the first thing, let's do the quick test here. So in this quick test, either we can give like the image URL or upload the images. So I'm going to do the Google search again, sailboat. So I'm going to pick a random sailboat like this here. I'm copying the image address and going back to this customization portal and giving this image URL here and clicking enter. So this is a sailboat, and you can see the prediction in the right hand side. So the prediction is like the sailboat 99.5% confidence, and the other boat type is like less than 1%. So that means like it's correctly detected this boat is a sailboat. Let's try with the other boat types. For example, like ferry or cruise. Let's go to the cruise ship picture. Let's take some little bit tough one to find. Let's take this one. Let's see like whether it's able to figure out like this is the cruise or not, right? I'm copying the image address here, same thing, going to the portal, uploading it here, cruise. Yeah, see here the probability rate or the percentage rate is like a little bit confused. It's confusing between cruise and ferry, but still cruise is like more than 50% confident prediction percentage. So we can say like this picture is cruise. Now let's take like the other thing, kayaking. Kayak picture. Yeah, we will take like this. Copy image address, going to this one. Kayaking is like a 99.9% confident that this boat is kayak. So like this you can have this the prediction, and once the prediction is done, you can include that into your training image. For example, this cruise is like 66.2%, right? So what we are going to do is we are going to tag it as like cruise, so that like it would include this image into like a next iteration of training. So I'm tagging this cruise and uploading that. This is already confident, but I'm saying like this is I will ignore this one second. So what you can see is like going back to this training image. I think you need to do another training, include that the prediction URL. So if like a new data is coming and there is some confusion, if you feel like you want to train a new iteration for the model, you can just upload the picture into that project again and do the new iteration. And once iteration 2 is done, it would be generating a new model ID in the sense, like if you go to the prediction URL, you can see like oh, they don't have this one. I think one second, I'm just looking like whether the prediction URL is changing or not. Prediction key is here. I think that is for every project. Is it not? Okay, I'm just checking like how it's okay. The same key. This is the key I'm using for my API key, so it needs to be secured. I would be changing. Okay, so here is a URL. Big text box. Okay, so this is the iteration 1 thing, and if you go here and copy this one, this is iteration 2. You can see like this is the project ID, and after the URL, the iteration ID. So once you are building like a new iteration, you just need to take care of this iteration ID. So just like have it as an environment variable, and once you have new iteration, just inject this iteration ID and do the latest prediction. So that's how these things work. And the prediction URL also we have tested, right? Now they have this export option. So what's that? I will make the iteration 2 as a default one. So they have this export option. What is that export option in the sense, like you can export into like multiple platform. You can export these machine learning things into multiple platform, including CoreML, TensorFlow, ONNX, and Dockerfile. So if you are using like iOS 11 CoreML model, just export this model into CoreML, and you can use the CoreML platform kit in iOS 11 or latest iOS version. Then you can use the CoreML APIs from iOS to predict the images in your machine itself. If you are choosing the domain which is not compact, I think this option would not come. You need to choose like only the compact domain, then only you can export this model to run it in your device. And for Android, they are having this TensorFlow. So if you are using TensorFlow in Android device, then you can export the model into TensorFlow model. And for Windows machine learning layer, they are using ONNX. And if you are running this in IoT Edge or Sir functions or the machine learning studio, then you can export this into the Docker file, right? So we are going to run this on IoT Edge, but let's see like how this Docker file looks. So I'm going to export this machine learning thing into the Docker file, and it's asking me to choose a version. Obviously I'm in the Mac OS, so I'm going to choose the Linux version. Let's see like what the Windows version also looks like. So right now what's going on right now, it's like it's exporting the machine learning model, and using the Docker file you can like predict the model in your device itself. That's what we have seen. Okay, it's getting ready. I'm downloading the Linux version. Probably I will download the Windows version also. Let's see. Okay, it's downloading the Windows version. In the meanwhile, let me go to the downloads and inspect like what the file it's generated for Docker. Okay, downloads, and what it is, there is a Docker file. codes to, I think this one. Yeah, 75, that means citation 1. Am I downloading iteration 1? No, right, iteration 2 only. Okay, so this one will go. So going to 75, whatever that, then opening this in Visual Studio Code. So it has this app folder. Azure, are you able to see? Okay, I'll just. It has app folder, Azure ML, Docker file. So if you go to the Docker file, you can see this is the Python container, and it's upgrading the Python pip modules, and it's installing app/requirements.txt. That is here. So it's installing TensorFlow, Pillow, NumPy, Flask. I think Flask is for HTTP server. So it's installing the requirements, it's exposing the port 80, setting the work directory app, and it's running app.py. And if you go to the app.py, they're importing JSON, OS, IO. They're importing the Flask module for REST API, and PAL from image processing. I'm not sure what this is. I'm just reading. I don't know the Python very well. From predict, initialize predict image, predict URL. Okay. So what it's doing is 4 MB max image size for the config, and it's setting up the default route. Okay. So the default route, it's returning custommission.ai model host harness, and /image post and /project image no store. This is doing this predict image. I think this predict image is coming from predict, and this predict tag is where it is coming from. Import from predict, import, initialize. Okay, so the predict image, I think this is some. Oh, predict is here. So the predict here, predict. Okay, so here you can see it's having this the pb file, model.pb. So you can go in here. This is the TensorFlow file, and you can see the list of tags that is associated with that image. So these are the tags we have uploaded, right? And this is the model that is generated for that iteration. So what this predict is basically doing is it loading the module using the TensorFlow, and it's doing all the stuff which I'm not sure. It's cropping the center, resizing, predicting the URL. Okay, so it's opening the URL, predicting the image. Let's go to the predict image. So predicting image, if it is not RGB, then it's converting to RGB. Then updating orientation based on EXIF tags, and it's doing some resizing. Okay, so here it's converting to the NumPy array and extracting and resizing to 256 square, and propping the center, and using the TensorFlow session, it's running the session here using these prop sensors by giving the layer. Okay, so something happening with this tensor stuff. Basically the TensorFlow model, it's picking up the tensor algorithm, and it's doing the predictions on those images. So here is the result you are getting, the truncated probability. So that probability will be coming here with the tag name and the probability. And once that is done, it's returning the response, and the app.py is the REST-based server that is built using the Python, and predict.py is the core thing which is running the TensorFlow model prediction. So they have put everything together in this Docker file. So let's go and run the Docker. I think they have some readme. So docker build -t your image name and docker run. Okay, so let's do that one. So docker build -t. I would name like a board classification. Oh, I don't have docker here. Brew cask. I think docker has a different script, right? I think Brew has a Docker. Let's do that. I didn't set up the Docker yet here. So let's go back to this custom mission portal. Sorry, let's go back to this code. So once that is done, then we are running it into the localhost 80 portal, uploading the image, uploading the URL. We have this Azure ML as well. Azure ML image in this package, copying thing, 4 files, and creating the manifest, register the model. Okay, let's see whether Docker is installing. You will see. I think Docker has, otherwise I would just download that. I think I have Docker ID. I think Docker C is for Linux, right? From the apt repository. Okay, it's downloading these files. So let's open the Docker image here. Docker. Drag and dropping to the application. So going to the Docker. We are very happy to have you. Okay, so here see Shiva 1 2 3. Okay, Docker desktop is starting. Okay, now let's go and see like whether Docker is available in here. Okay, Docker is available. So the couple of things we need to do is go to this readme text files and Docker build and tag my image like boot classification. Okay, it's pulling all the images it required. So what it's going to do is it's pulling the Python 3.5 image. It's downloading things. Okay, and it's doing the next step in the Docker, including like you can see the step 2 is adding the app and running the upgrade and installing the requirements. So here you can see like it's downloading the Tensor flow from that the PIP, and it's installing the requirements. So once that is done, then it's exposing the port and it's going to run the Python app.py. Okay, I think it's successfully built. That stuff, we'll be waiting. Okay, so now the Docker image is like successfully built. The next thing we need to do is run the Docker image. So let's go back to this readme, how to run locally. So docker run -p127. okay, I will copy this thing, and our image is boot classification. Now it's running. So if you hit that curl, I think there is a get endpoint as well, right? Yeah, the default route it's returning custom. So curl -x http 127.0.0. Oh, instead I'll just like put it in here. 127.0.0.1. So now you can see like it's returning the custommission.ai model host harness that's coming from this get request. So if you need to post the data, you can just like post it here, and it has a couple of objects as well, like slash image, project image. Okay, now go back to the readme again. So it has multi-part form data, and also we can provide the URL here. So we will take this one and try with the URL. So going back to our test stuff. So let's take some another kayaking picture. I'll take this one, copying the image address and coming back to the example. I just insert the URL here, copy this curl command and paste it here. So what it's going to do is it's going to post the image, could not pre-process image for prediction, cannot feed value of okay, some error came from the tensor. Usually it should not be, why I'm not sure. Let's do this thing in the prediction there. Sorry, quick test. Here it's predicting, so some error happened in running in the local. Is it right, or maybe I'm wrong? How it's cannot feed value of shape for TensorFlow placeholder which has shape. It's not able to predict this the X value here. Okay, so let me do that the different thing. What are the other stuff they have provided? Data binary, some file name. I'm not sure how this. Okay, I will try this one. So opening this and going back to boat's image itself. Let's go to sailboat, and it has this many pictures. So I'm going to pick up one of the picture. Why? Oh, sorry, not the file. Probably water ski something. Water sea travel. I am getting like a this one. I'm trying to run from Docker. I'm getting this error. I'm not sure why. Okay, yeah, the same error I'm getting. Cannot feed value of shape for tensor placeholder 0. Why? I tried the octet stream as well. Something different. So that means like it's trying to upload the picture, but it's not. Okay, let's see. Could not pre-process image for prediction. Custom mission. I want to run this in TensorFlow. What's the other thing? Cannot feed value of shape. Okay, so this is the TensorFlow error I am getting. You need to reshape X. Okay, let's add a custom mission. Okay, they are saying like a reshape only. X dot, okay, you can use x equal to image preloader. You can use x equal to x dot reshape, whatever this one. Okay, now for us, like I'm just looking like I'm looking the previous image, what it's 224 224 3, here 224 2, the same thing, right? So we need to reshape that one. Cannot feed value of tensor shop. You can use x equal to x dot reshape. Okay, I think now it's time to look at this predict.py. So the first thing, so preparing the data. So this is the convolution network. I don't know what this is. Okay, now let's go back and see this one. So 224 224 3. I'm not sure like where this is one. I'm just looking, I don't have any size. So the network input size, this is 227. So this is what it's trying to do, and it's trying to do the crop center, I think. Okay, here it is, the crop center. Image shape, start x, start y. Okay, let's see the logs that's coming from container. Docker logs. I forgot the container name. It is okay. Docker ps -a, and container ID is here. Docker logs, container ID. Okay, it's having this 500 server error. Oh, okay. Your CPU supports a Tensor. It's not compiled to use. Okay, I don't know what's this error. CPU feature god.cc. Your CPU supports instruction that this TensorFlow binary was not compiled to use. Okay, I will look into this one. CPU feature god. Okay, so this is the error we got. Those are simply warnings. They are just informing you if you build tensor build from source, it can be faster on your machine. Okay, so those instructions are not enabled by defaults on the builds available, I think, to be compatible with more CPUs as possible. If you have any other doubt regarding, please feel free to ask. If you are on your Unix system, simply do export tfcpp min log level 2. Yeah. Okay, I think if that's a warning, then we don't need to worry about that. But I'm just thinking like, why this 500 error, right? So going to the app.py, I'm posting it into the image. So here it's getting the image data, image.open, JSONify, and printing the exception. I think we are not getting any exception here, just like post stuff. How to do? Okay. I'm trying. Could not pre-process image for prediction. Okay, I will run it locally. I don't have any Python expertise or anything here. I will run 75. 90. Okay, so going to app, I think I should be having Python, but it's 2.75. Let's see. Control C. How to do that? Exit. Okay, so Python app.py. So before that I need to install the Docker file instruction here. So pip install -r and requirements.txt. Okay, Python 2.7 will reach the end of January 1st, 2020. Okay, I think that's the one default coming from Mac, but let's see. Okay, it's downloading all that the requirements text file what we have mentioned. So instead of like running in the Docker, I'm trying to run it in the local so that I can debug like what's going on in that the tensor flow prediction. Installing all the packages. Do you need like any Python ID or something? I'm not sure about the Python ID, or I think VS Code itself will have the Python support, right? Python in Visual Studio Code, Python in Terminal, autocomplete, IntelliSense. I need the debugging stuff. So I can set up my launch.json. Okay, this is what I want. Let's install that extension. How to install the extension? Command Shift P, install extensions, Python. Okay, so I'm installing VS Code Python here to debug the Python project that is generated. Is it the old version? It's asking like reload required, but in the latest version of the Visual Studio Code, this is not needed. Oh, it says like there are currently no updates available. Oh, I remember like certain extensions still require the reload required. Okay, anyway, that's like pretty fast. So I have this Python extension installed in the VS Code, so that's right. Now I am trying to debug this one. I will open the app folder here. Code. App.py. So I put a breakpoint and I will add the launch. How to add that VS Code extension? Not the extension. I'm trying to set up like the launch configuration. Okay, where it is? Okay, so going to this debug and the Python current file and Python remote attach, Python module, Python flask. Oh, there are a lot of things added. I don't know what to do. Add. Is it a Python module? I think Python current file. Okay, it's running the Python in the Visual Studio Code, and it's running this app.python, which is basically the REST server. Okay, uh, I got some error. Python launcher loading model end. This is from the predict.py, right? It says invalid syntax. Let's go to the predict.py. Okay, maybe I need to update my Python version. How to update the Python version? 3.5, right? Install Mac. I think I need to run with the Python 3. Okay, the brew install Python. This will take a minute or two. I'm upgrading my Python to 3.5. So right now my system has 2.7 Python. So I'm updating to Python 3.5 and make sure like this file is able to debug from the VS Code. I'm getting the weird error in this placeholder 0 thing, so I'm going to debug this TensorFlow code that is generated using the customization portal. Okay, till that we will see what's happened here. It says invalid syntax, loading model, line number 23. So if you go to the predict.py, line number 23, why it is invalid syntax? I don't know what this is. I just probably remove this like this. Okay, now they still I'm getting this error. Invalid syntax, line number 23. Oh, I think I don't need this one. The same thing it's happening here also. Or maybe this is the latest syntax. I don't know what's going on here. Okay, so Python 3 is installed. Python version. Okay, Control D. Python version. Still okay. Python 3 version. Yes, so that is right. Now if I am trying to go to the launch.json, Python current file debug, still it's compiling through Python 2 only. Okay, or 1 second, I will do the like this. Instead of the VS Code, I'm just running from Python 3 app.py. I install this. Okay, requirements.txt. I install all this Python module, right? No matching distributions found for requirements.txt. Okay, something going crazy here, but I will test this one afterwards. But this is the TensorFlow generator, so probably the next stream, I think you'll be coming to the end. On the next stream we would be debugging this the Docker file, how to run the prediction using this Docker file that is generated using the prediction, right? Or like we can use directly hit the prediction URL endpoint, but I don't want that one because we are going to run this Docker on IoT Edge. so that the prediction would be happen in that IoT device itself instead of hitting the prediction URL endpoint that's running on the cloud, right? So what we can do is like we can do the prediction using the Node.js API as well. We're having this Azure SDK for JS, using this cognitive service custom mission training and also the custom mission prediction. So we will be using these two models for like doing the prediction and the training. Okay, so we will be doing this authentication and other stuff. For Node.js based authentication, look at MS REST Node Auth. Oh, it's going to the deprecated version. Let's MS REST Node Auth and MS based MS REST Node Auth to do that authentication for the Node.js application, and MS REST browser auth. This is for like doing the browser authentication from the Azure thing. But this one is renamed to this stuff. I think it has a new URL. Yeah, so we will update this documentation here to point it to the new URL. Let's do the PR, going to this readme. I will fork this one. Forking into my repository. I'm going to update the readme and create the PR to point it to the new it's still pointing to the deprecated npm package, so we would be updated the document to point it to the new packages. So this what like we have looked at today, right? So we have looked like what is custom mission, and we have downloaded the data sets from Kaggle. It has like a lot of data sets. You can use that for like a machine learning or your data science things. So for today's session, we just like take this board type recognition data set, and we uploaded that board types into custom mission portal, and we have tagged each image. For example, what cruise it is. So it has like the different board types. You can see like cruise images, ferry, gondola, kayak, sail. So we uploaded all these different classification of board types, and we have tagged that image. And once we tagged that, we went for training, and we see like how the model is performed very well here. And even like if you are adding new images, we can create like a iteration for the trained model. And once the model is trained, you can create a prediction URL to do the prediction, or otherwise you can go to the quick test here, and you can browse any file. For example, here let's go upload one of the ferry board. Then it's doing the prediction, and it's 99.5% confident that this is the ferry boat. So these kind of board classification and the prediction we have seen. The next thing what we have seen is like we just try to export this Docker file from the pre-trained model, and we try to run the Docker file, but we face some of the issue from the TensorFlow, how it's predicting the image. So we are trying to fix that, but let's continue that in the tomorrow session. In the meanwhile, when we are looking to this Azure SDK for JS repository, we saw this readme is pointing to the deprecated npm package. So I'm going to create the PR to update that one. So editing this, I think it's somewhere here, right? npmjs.com ms rest node auth. Instead of that, it should be under the Azure namespace. So I'm editing here. Oh, it's a browser auth. Okay, and ms rest node auth it should be under Azure package. So going back to this thing again, MS REST node authentication, it's moved to Azure node authentication. I think that's it, right? Yeah. So let's see, like updated, deprecated, update deprecated npm packages, npm package URLs. Okay, so committing to my fork master branch, and if I'm going here, it should be okay. New pull request, base repository master to master. Okay, so updated npm package Azure ms rest node auth, ms rest browser auth. If I'm viewing the file and clicking this, it should take me into the new repository, ms rest browser auth new repository. Okay, so I think this is good. Going back here, creating the pull request, update deprecated npm URL. Okay, so here what I need to do is readme update, updated readme authentication section, updated node.js based authentication, ms rest node auth to this one, and updated no browser based authentication package URL. That is a ms rest browser auth to ms based browser auth here. Okay, so one other thing I need to do is, before making this pull request, okay, I need to do another thing. Case what's the URL here? I need to edit like a what repository name it is as well. So going back to my okay, I just copy this one, going back, editing this. So instead of like this one, I would put like Azure, and here also Azure. Yeah, that's right. Update package names. Now going back here, creating a pull request, base repository, Azure ms rest node auth, Azure ms rest browser auth. Okay, this is right. Okay. Update deprecated package URLs. ms rest node auth. Okay, so updated this one and updated this one. Yeah, so creating the pull request. Okay, so the Azure SDK for JS pull request is done with minor document changes. Okay, my license already I have done like the peer request for Microsoft repository, so it's already licensed. So I'm just checking for like some of the continuous integration checks. It's running on the Azure DevOps, so whenever I'm checking in the code, it's making sure like I'm not breaking anything there. Okay, I think that's fine. I will just watch this PR so that yeah, I'll recap this notification on. Okay, I think that's it for today, guys. So we just that's it for today. So we just watch like we just look through what is custom mission and how to upload the data. So today we just upload like what are the different port types, and we have trained that model, and using the prediction URL we just predicted what type of boot it is. And also we have did a couple of we did like a PR to the document changes. It's pointing to the deprecated URL, so we updated to that the latest repository for this Azure SDK for JS Node.js repository. In the next session we will continuously fix that Docker file, why that Python is not running and why the image prediction is not running through the Docker image. We will see that one, and we will see like how we can run that in the Azure Machine Learning Studio, basically like from the Docker. Then at last like we would try to run this Docker image in any of the IoT device. So that's our goal for our next stream. So till then, bye, see you tomorrow. Tomorrow I will be streaming on same timing, 8 p.m. EST. So we will be seeing at the time. Okay.